Hi everyone, for this video we're going to discuss qualitatively how the pressure of the gas varies with the volume of the chamber is in, and this time we keep the temperature constant. And I want you to observe three things: the number of collisions between the air molecules and the wall per unit area, number of collisions between the molecules and the wall per unit time, and the speed at which the molecules collide with the walls. Now, if I want to decrease the volume, so I'm going to make the chamber smaller. Right, focus on one section of the chamber. You'll notice that the average speed on the molecules actually remains constant. And because the average speed on the molecules remains constant, the temperature of the gas also remains constant. But you also notice that the average distance traveled by the molecules from one end of the wall to the other end of the wall also decreases because the chamber is now smaller. And if I were to isolate one small area of the wall, I also notice that the number of collisions per unit area increases, and the number of collisions per unit time also increases. But since the speed of the molecules remains constant, the force at which the molecules collide with the wall also remains constant. As such, since only the number of collisions per unit area per unit time increases, but although the speed at which the molecules hit the wall is constant, the pressure of the gas increases. So here, the pressure of the gas increases is because of the number of collisions per unit area per unit time. Now let's zoom out, and then we're going to increase the volume of this chamber now. So with the volume of the chamber increase, you notice that the average speed of the molecules still remains constant. Okay, in order to determine that, just zoom in on one molecule. You realize that it still remains constant. Therefore, the temperature of the gas remains constant. Also note, now the average distance traveled by the molecules from one wall to the next wall has increased. And if I were to isolate a small section of a wall, you also notice that the number of collisions per unit area decreases. The number of collisions per unit time also decreases. But since the speed of the molecules remains constant, the force at which the molecules collide with the wall remains constant. And since only the number of collisions per unit area per unit time decreases, we say that the pressure of the gas has decreased. So to summarize, how does volume varies with pressure when the temperature is constant? So when the volume decreases, the pressure of the gas increases. And when the volume of the gas increases, the pressure of the gas decreases. Okay, to tackle such problems, focus on the number of collisions per unit area per unit time. And as the temperature is also constant for this case.